All right, so we're going to talk about absolute value. So when you take the absolute value of a number, you always end up with positive. Absolute value is actually distance. So it doesn't matter if I go backwards 3 feet or forwards 3 feet, I've gone a distance of 3 feet either way, even though technically we signify backwards as like a negative. So we know that the absolute value of x, if absolute value of x equals 3, there's two things that could happen. We know that the absolute value of 3 equals 3, and the absolute value of negative 3 equals 3. So there's two possible things that this part inside the absolute value could equal, that it would give me the answer 3. So when we're solving absolute value equations, we're going to set what's inside the absolute value symbol equal to the given number and its opposite. So always have to have two answers. So that means we have to get the absolute value all by itself. And then once it's all by itself, we got to set that inside equal to what, to the number. So we want to get this part right here equal to itself. So we subtract 7. So we get 2 absolute value of x equals negative or equals positive 4. And then we're going to divide by 2. So now we have the absolute value of x equals 2. So we know, as we discussed up there, there's two things that this x could equal. X either equals 2 or x equals negative 2. So if I look at that on a graph, so we have a negative 2 is an answer. We're just going to put a solid circle there, and positive 2 is an answer, not a range. Notice, remember I said absolute value, what's inside of there is your distance. Notice that we wanted to know which two numbers has a distance then from two spaces from 0. And that is negative 2 has a distance of 2, and 2 has a distance of 2. So you can kind of see that there. But what I'm looking for is that graph that takes my two numbers. So absolute value should have two answers unless it's 0. If it's 0, then it will only have one answer. So let's look at another one here. I would pause the video and try this one and then see if you get the same thing that I do. Anytime you can practice and then check is super helpful to your learning. So I've got 3 over 7 absolute 3/7 x absolute value of x plus 6 equals 6. So we subtract 6. So I have 3 absolute value of x over 7 equals 0. So I'm going to get rid of this 3/7 because, again, I want to get the absolute value by itself by multiplying by 7/3. So then the 3's cancel, the 7 cancels. And I'm going to do that both sides. And I get absolute value of x equals 0. So anytime the absolute value part equals a 0, we just have one answer. So we're going to put x equal to 0, the inside part equal to 0, and we just have one answer to graph here. And I'm just going to put a dot at 0. All right. So here, absolute value is already by itself. We have a little bit more inside, but same thing. This x, whatever x is, plus 3, that the absolute value of that equals 5. So I would take the x plus 3, because it's all got the absolute value by itself, equal to 5, and solve for x. And x plus 3 equals to negative 5, because once they took whatever x was and added 3 to it. They took that value and they took the absolute value of it and they got 5. And that would mean that that has to be 5. So I'd subtract 3. X equals 2. Subtract 3. X equals -8. So my two answers, -8 I run out of room here, is my two answers are -8 and 2. So again, this is distance. It's no longer from 0, but it's actually from your from -3. You see the two numbers that are distance, and the -3 is coming from that +3 there. That equals 5 away from -3 are -8 and 3 and 2. All right, so let's look at it with absolute value. With inequalities. So there's two different cases that can happen. We're still going to do the opposite, but case 1 is that if the absolute value all by itself is less than a number, then that is going to be a conjunction where it's two cases of and. So it has to be that part inside the absolute value has to be greater than -a and less than a. If it is greater than a, then that breaks into a or. So either that absolute value is greater than a or less than -a. So you're going to want to know this so you can tell which case you're going to see. So we've got absolute value by itself. So we're going to set, so that is less than. So that means 5x plus 2 is either less than 7 or greater than negative 7. So remember we said this is two different equations. So we could do -7 is less than 5x plus 2, subtract 2. -9 is less than 5x, and then divide by 5. And this is an and, so we're only going to shade the part where they're both true. So -9/5 is less than x, or we could also write that as x is greater than -9/5. And then we have our second part of the equation. So 5x plus 2 is less than 7. Subtract 2. 5x is less than 5. Divide by 5. X is less than 1. So two situations, x has to be less than 1 and greater than -9/5. -9/5 equals a -1 and 4/5. So almost to -2. So I'm going to put in -2. All right, so it has to be greater than -9/5. So about to -2 is, and this is going to be an open circle. And it has to be greater than, so to the right of it, and less than 1. So it's an open circle at 1, and it's in between. You can kind of think of that as that when we change that to a negative, we kind of flip the sign. So notice it was less than, and so then the other case, the negative case, is going to be greater than. All right, let's look at one with our other situation. This one is greater than, so we would have the two situations. Absolute value is already by itself, so I don't have to move anything. So we have 4x minus 5 is greater than or equal to 15, or 4x minus 5 is less than or equal to negative 15. It's like I multiplied that by a negative, so that flipped my inequality. So we then would solve each inequality. X is greater than or equal to 5. Or x is less than or equal to negative 5 halves. So we have should probably have done that over, but that's okay. So we have greater than or equal to 5, so close circle at 5, and bigger. So two areas that would make it true. And or less than negative 5 halves, which is negative 2.5, close circle, and less than. So the ors, remember, are going out in both directions because it has to be one or the other. All right, I would graph this or solve this and then see what you get. And then I would pause the video and try it, and then I'm going to solve it for you. So looking at this one, it's less than. So my two cases would be, it's going to be an and. So 1/3 x minus 1 is less than or equal to 2. And you can write it this way if it's easier than the joined one. X minus 1 is greater than or equal to negative 2. You have to just know which one's going to be and which one's going to be or. So let's finish solving it out. So I have 1/3 x is less than or equal to 3. And then I'm going to multiply by the reciprocal, because dividing by a fraction is multiplying by the reciprocal. So x is less than or equal to 9. And our second case, again, multiply by the reciprocal. X has to be greater than or equal to negative 1. Less than 9, greater than negative 1. So less than or equal to 9, so to the left of 9, and greater than or equal to negative 1. So it's in between those two.